Hello, I'm Pushkar, Master Teacher in Chemistry at Vedantu, and I'm discussing the Advanced 2019 Chemistry paper solutions. Here, the question is related to the mole concept, question number 10. A very simple question. Let's see what is the question and how to solve it. In this question, the mole fraction of urea is given containing 900 grams of water is 0.05. So that means mole fraction of water is also given. And density of solution is also provided. If the density of solution is 1.2 grams per cc, the molarity of urea solution is. So a straightforward question in which we have to relate the molarity to mole fraction and density. So there are various approaches to solve this problem. So let us see what are the simplest one. So mole fraction of urea is 0.05. That means mole fraction of urea is equals to 0.05 and mole fraction of water must be 0.95. So if you have to find the molarity, what is molarity? Molarity is equals to number of moles of solute divided by volume of solution in liters. So obviously to find the molarity, first of all, let us assume that we have 1 mole of solution. And in this 1 mole, we have 0.05 mole of urea and 0.95 moles of water. So proceeding further, that means mass of urea is equals to 0.05 into 60 grams. Mass of water is equals to 0.95 into 18 gram, and mole of urea here is equals to mole of urea is 0.05 mole. So that means molarity is equal to 0.05 divided by 0.05 into 60 plus 0.95 into 18. This quantity is basically what in the denominator right now is the mass of solution. And if we divide this mass of solution by the density of solution, if we divide it by density of solution D, it is going to give us the volume of solution. But the density here is equals to 1.2 grams per cc. So that means you are going to get, if we substitute this value of density here, 1.2, what we are going to get, that means if we substitute here 1.2, this quantity in denominator is right now the volume, but this volume is in ml. So we have to divide it by 1000 to convert it into liters. So basically that will be molarity. So it comes out to be 0.05 into 1.2 into 1000, and this divided by 0.05 into 60 plus 0.95 into 18. And when we solve it, we'll get the molarity. That could be the one way of solving the problem. Simply going by the basic definition. And if we solve it, we are going to get answer which is equal to 2.98507. Can we do it also by the formula? So let us try a formula. The molarity will become mole fraction of solute. Suppose XB stands for mole fraction of solute, okay? So this divided by XB into molecular mass of solute plus 1 minus XB into molecular mass of solvent. Let's call molecular mass of solute Mb and molecular mass of solvent Ma. This quantity in the denominator is basically the mass of the solution, and then we have to divide it by density. That means let's multiply here by density in grams per cc and into 1000. So that is the formula through which we can immediately get the value of what? Molarity. Basically the same thing we have done before. We can do it simply in form of the formula. It is not advisable to remember this formula. Do it with the basic method, but nevertheless you can say that of course you can relate molarity to the mole fraction and molarity to the mole fraction as well. So that will be the expression. Pretty straightforward. Now you have a printed solution. Here we have also done it in a simplest possible manner. And answer is after truncation 2.99. So I hope that you understand this problem. Quite an easy problem, the mole concept. Stay tuned for solutions to the next questions. Thank you.